Hi learners, welcome to the next class. Today we are going to discuss the properties of direction derivatives. Mainly as discussed three properties of direction derivatives. Then these properties are mainly classified as to the value of theta. That the value of theta means the value of cos theta. Then the cos theta values based to these properties are coming. Then the values are how to going to discuss the how to calculate the value, how to mention the value, then how to calculate it. These things are to discuss on here. Okay, going to the topic. First of all, to duf, we already studied this. When what's things the derivative of f in the direction of u at a point p naught. Derivative of f in the direction of u at a point p naught. How do I write? Gradient of f dot u is a gradient of f in the direction. Is a dot product of the gradient of f in direction of u equal to mod gradient f mod u cos theta. Then simply to write mod gradient f cos theta. Then the theta value based the properties are come under. Then first property, the value of the cos theta is equal to 1. Then the theta value equal to 0. That means the angle theta is based on the angle. How to measure the angle? Then the angle measure the angle between what are things gradient f and u. Angle between gradient f and u is the angle, the theta value. Then first property cos theta is equal to 1, theta equal to 0. Then is same things on is theta value is 1 is positive value. Then increasing most rapidly. What is increasing most rapidly? Increasing most rapidly. That means to increase functions, to increasing to from the level to increasing high levels. Then second things is opposite of the first property. That it means to come to decreasing. How do you decreasing? The value of cos theta equal to minus 1. Value of cos theta is minus 1. The theta value is pi. Theta value is pi. Then the cos theta equal to minus 1. Then what we get? The function is decreasing most rapidly. That means minimum value. It's a maximum value. It's a minimum value. Decreasing most rapidly. The function f decreasing most rapidly. Decreasing most rapidly. Then come to down. Then the gradient of a function get minus is here positive will be positive gradient f, then will be minus gradient f. Is increasing will be positive, then get the positive, then decreasing is get negative. Third one is get positive and negative. What third one is neutral. What's a neutral? Neutral means theta value how much? Theta equal to cos theta is neutral, then we have theta value theta pi by 2. Then cos theta is equal to 0. Then the duf equal to 0. And then pi by 2. Then the value of cos theta is 0. The direction derivative, direction of f with the derivative u equal to 0. And the function is no change. Right? Good. No change. Function is no change. Then what we get is a 0 function. Duf will be 0 icon. 0 then function the orthogonal to the direction. Here will be increasing. Here will be decreasing. Third one orthogonal. Orthogonal to the function. From the orthogonal to the direction, not for function. It's a direction. Orthogonal to the direction of orthogonal to the direction. Which direction? Gradient f. These are the three properties. First property will increasing, second property decreasing, third property neutral. This will be function to neutral, the direction of the orthogonal to the direction of the gradient f. Then the value of gradient f is a positive, so negative is neutral. Then we come to a level, so to middle, that things. Then we to get more details, do for a problem, then go into a problem. Just example problems, then we get more details. They're going to discuss the problem. First, find the direction in which f of x comma y equal to x square plus xy plus y square increase most rapidly. Increase most rapidly means which condition, which property? First property. And decrease most rapidly the point. Decrease most rapidly which property? Second property. Then the point 1 comma 1. What are the directions of zero change if at 1 comma 1? If the f is at 1 comma 1, the point 1 comma 1 is a zero change. That the third property. What we name the what are the directions of zero change f at 0 comma 1? Okay, going to solution. What's given f of x comma y equal to x square plus xy plus y square. Then to find increasing most rapidly and decreasing most rapidly at the points 1 comma 1. Then come to a dou f divided by dou differentiating function, dou f divided by dou x 1 comma 1 the point. What do it? 2x plus y 1 comma 1 equal to 3. To substitute the value, we get 3. Next step, dou f divided by dou y 1 comma 1 with respect to y, what we get as the same as 3. Then gradient of f 1 comma 1 equal to addition to this dou f divided by dou x 1 comma 1 I vector plus dou f divided by dou y 1 comma 1 j vector. To this one and this two add here. Then what we get? 3 plus 3, 3i plus 3j. 3i plus 3j is a value of gradient f 1 comma 1. Then this increase most rapidly means gradient f at point 1 comma 1. These are questions in the question. Then increasing means to first property, using the first property. Then the u at a point, u equal to 3i plus 3j divided by mod 3i plus 3j. 3i plus 3j, here we get 3i plus 3j divided by mod 3i plus 3j equal to 3i plus 3j divided by, take 3 square plus 3 square, square root of 3 square plus 3 square, what we get? 3 square plus 3 square, 9 plus 9, 18, 18 it, what we get? 9 into 2 is right. 3 plus 3j divided by 9 root 2. Sorry, 3 root 2. What we get? 3 root 2. 9 into 2, that means 3 root 2. Then cut it 3 and 3. Take 3 and 3 outside. 3 of I plus j divided by 3 root 2. 3 cut. What we get? 1 by root 2 I vector plus 1 by root 2 j vector. 1 by root 2 I vector plus 1 by root 2 j vector. I think this much is clear. Then going to the remaining steps. First property satisfied. Then going to the second property. What second property? Minus gradient of the point 1 0 comma 0. What we get? First property u equal to 1 by root 2 I vector plus 1 by root 2 j vector. Then second property, the minus gradient of then the minus u. Then get minus 1 by root 2 I vector plus minus 1 by root 2 j vector. This is a second property. Then going to third things. Third is a neutral, is orthogonal. Then going to third things, f of at 1 comma 1 gradient f at 1 comma 1. Then neutral, then take a constant ai plus bj. The gradient f ai plus bj equals 0. Then 3i plus 3j dot ai plus bj. For 3a plus 3b equal to 0. 3a plus 3a plus 3b equal to 0. Then substituting dot product, using the dot product. Then put the value a equal to minus 1, b equal to 1. A equal to minus 1, b equal to 1. Then 3a plus b equal to 0 is already get. Then minus 1 I plus j. Minus 1 I plus j, a plus b. Then orthogonal to gradient f. It's the third condition, orthogonal to gradient f. Then get n equal to minus I plus j divided by square root of minus 1 square plus 1 square. Take more than square root. Minus 1 by root 2 I plus 1 by root 2 j. These are third condition. Then the value of n equal to minus 1 by root 2 I plus 1 by root 2 j and minus n equal to 1 by root 2 I minus 1 by root 2 j. These are the n value and minus n value. This is what we find. What are the directions of zero changing in f at 1 comma 1? This one we're going to find is get n of 1 by root 2 minus 1 by root 2 I vector plus 1 by root 2 j vector and minus n equal to 1 by root 2 I vector plus minus 1 by root 2 j vector. Okay, thank you. Hey, hi learners. Today we are going to discuss topic tangent to level curves. Everyone to know the tangent lines. Then the point is a graph take x, y, then the curve is a kind of a tangent line. Here we are same asked to do f of x by function of two variable x and y as a variable. Then the equation for tangent line level curves of a tangent line of level curve of the function. Then we we are going to find the equation for the tangent lines of the lower curve f. What we find equation of the tangent line of the lower curve f. We're going to find the equation of tangent line of the lower curve f. Then we essential for as first we check the results or what the results to say a results to be a point f of x naught y. As I take a point x naught comma y naught. It's a point x naught comma y naught in the domain, which domain x naught y naught is which domain to have f at x comma y. As domain is kind of x comma y in the gradient of which gradient to normally to know the gradient of f is a normal level curve. Remember at the point x naught y naught you already studied the point x naught y naught or x p naught of the point p naught. Then the gradient of f of the direction of u. Then here with the point x naught y naught the gradient of function of domain of f at x comma y, then the gradient of f is normal to a level curve, which is normal to a level. And study about the curves, then going to f is a normal to a f is normal to a level curve. Normal to a level curve that to which point through the point of x naught y naught. Through which point to x naught comma y naught. These are things for the say the results as like before the says to results. That means the level curve to as a point of xy. So two dimensional space. Then want to find the equation of tangent line to a level curve. Then to know the at the point x naught y naught of the domain f x naught comma y naught to a gradient of f is normal to a level curve. Gradient of f is normal to a level curve then through x naught y naught. Then x naught y naught going to x naught y naught the point to the level curve f as normal. Then it means to know that about equation I will say that this means to gradient of f is normal to tangent vector. That means the gradient of f is a differential with r by t equal to 0. Then the gradient of f dr by dt equals 0. Then dr by dt is normal to curve. This means to normal to curve. Then what we get dr by dt is normal to curve. Normal to a curve. Then the gradient of f is normal. Gradient of f is always to know the normal to curve. Then the dr by dt is also to be normal to a curve. Then we confuse this dr by dt how to get. Then the point of the r equal to gt of I vector plus h of t in the j vector. As a 2 points of I vector and j vector to take as r as a g of I vector and g of h of t the j vector to reduce the function or to differentiate it to get the dr by dt equal to 0. Then both are to normal to a curve. Then come to equation. The x naught y naught is a point, already told x naught y naught is a point of domain of f, x naught y naught point the domain of x comma y. Then the result of the curve is just get the results of curve to f of x comma y the point. I will write as f of x comma is a point as the point of the level curve is towards the point through x naught comma y naught, to the point x naught comma y naught. Then the equations to get and at the point equal to ai plus bj. Then the point ai plus bj. Then we write the starting point is x naught y naught and a function of x comma y. Then what we get is a of x minus x naught plus b of y minus y naught equal to, so what's get equal to 0, then the value will be 0, then the data function to 0 is normal curve to be 0, then the value of I plus bj. I plus is different to as ai. I have to write as x minus x naught. The initial point and to say differences. Say starting point, ending point, point to start point. X minus x naught plus b of y minus y naught equal to 0. Then the gradient of function n is to take as a gradient, n as what now the value what gets the gradient function. Gradient to get what we get, and is a gradient to take the gradient vector to go the point of the gradient of f x naught y naught. To take n as to the gradient, want to take a point as x naught y naught, then to f of x naught y naught, then fx of x naught comma y naught, sorry, fx of x naught comma y naught, and to I vector to write it down to get what we get fx then plus fy of x naught comma y naught set j vector. Then the to how to get this, say gradient of n has to take a gradient and the initial point of x naught y naught, then the fx of the derivative function x, then x naught comma y naught is I vector plus y x naught comma y naught is j vector, then both I and j to as I plus bj, because n is I plus bj, then the gradient to take of this to the gradient of this function to become to write fx of x naught comma y naught or point x minus x naught plus fy of x naught comma y naught as an initial point y minus y naught equal to 0. Then I need to know that equation has to be equal 0, then a of x minus x naught and plus b of y minus y naught equal to 0. Then the value of a2 changes fx of x naught comma y naught and b2 changes fy of x naught comma y naught. This equation to say that the tangent line of globe curve x naught y naught at the point at x naught y naught. This is the main equation to say that the coefficient to take right fx of x naught comma y naught and x minus x naught plus fy of x naught comma y naught y of minus y naught equal to 0. This is an equation to that the tangent line of curve to the point at x naught comma y as at which point x naught y naught. Then going to problem, then easy to understand and easy to recall that things. A problem just we take as so find an equation for the tangent to a circle x squared plus y squared 4. Then right on here, what the solution, the point 0, minus 2, say x on y naught point. Then go to solution, what we get as a level curve function f of x comma y equal to, we get x squared plus y squared, x squared plus y squared. Then point to find value fx and fa on the point 0, minus 2 of fx and fy. Fx, what we get x squared, then we see 2x, and fy equal to 2y. Then f of fx of 0, minus 2 as a point equal to 0, and fy of 0, minus 2 as a point, what we get minus 4. Then the gradient vector to apply on here, what we get gradient vector, what we get I and j to what is 0 plus I as 0 vector. That means the gradient f to go point 0, minus 2 equal to fx of I vector plus fy of j vector. Then the point has 0 comma minus 2. Then substitute each values on here. Fx value be to xi vector plus 2y j vector. And the point 0 comma minus 2. Then what we get? So the x value be 0, then get minus 4j. I think is understand to that as the point of the gradient of f 0 comma minus 2, then fx I vector and fy to find it, then get us put the point or the x value and y value or to fx of I to get equal to 2x I vector and fy I vector is equal to I j vector. Then they substitute the point 0 comma minus 2, then get minus 4 plus j. Hence equation of tangent circles, then going to find hence the equation of which one tangent to a curve circle, or for curve is circle, tangent to the just we write the equation. First of all, to write the equation, then we write is easy to understand. Then fx of x naught comma y naught, then the x minus x naught plus fy of x naught comma y naught y minus y naught. Then substitute on here what we get, the value of fx comma y naught will be 0. Then go substitute on here is also equal to 0. Then is substitute on here what we get, this will be 0 and x minus 0 based on that point plus fy is minus 4 y plus get 2 plus 2 equal to 0. Then what we get, 2 plus y, what we get also 2y minus 4 into y plus 2. Then what we get, 4 is into my what of y plus 2, then with the value of y, the value of minus 2. Then get the value of y's value is minus 2x will be, so on y value is minus 2, these things. Then here we using the equation as the last we studied the equation of the level of curves of tangent to level of curve equation. These are main equation. To remind the equation, be easy to run the problem.